but not cutting it.
That's right. Please start Sam.
That would be me.
Hey, Sam.
Oh, hey, look, Zoom finally updated my screen name. Okay, so let me activate my video real quick. So hello everyone, my name is, well, Sam Falvo, as you can see, and I've been on and off throughout the years working on homemade computers. And I've always had this vision of replicating, I guess you can say, the user experience of a Jupyter Ace. It's just something that has always fascinated me, but I wanted it to be a more up-to-date computer design, having access to more memory, having access to more modern peripherals, that sort of thing. And this project started in 2004, and it has morphed here and there throughout the years. And as one would expect from such things, I got woefully distracted, ended up going into FPGAs, ended up doing all sorts of different things. And yeah, that project never came to fruition. So, and as is typical for me, I start a ton of projects and I never finished it. One particular day I made an SVFIG presentation and I got a comment on that saying, well, when are you going to finish projects? And so that kind of got me thinking, you know, maybe I should just take a step back and go back to my roots and start working on the very first computer that I ever designed on a breadboard, but never actually finished, and actually quote unquote finish it. Part of that involves, of course, writing the system software for that machine. But since I don't actually have any hardware, that means that I have to do this all in emulation. So that kind of brings us to today, where I'm kind of working on system software. It's not forth yet, but it will be there. But in the meantime, in order to whet the appetites or satisfy the appetites of people who've been waiting for a while, even for an emulation of the computer, I worked on a port of a machine language monitor called TIM. Now, if you're familiar with Commodore 8-bit computers, you should already be familiar with TIM. It's the machine language monitor that is essentially standard on that particular family of computers platform. So it's used, it looks, it behaves quite the same. It's not 100% feature complete, but we will get there eventually. And part of this update is to show that I've made progress in that area. So let me share my screen real quick. There it is, the big green button that's sitting right in front of my face. Let's see here. Okay, so this is my terminal window. And so K1EMU, it's an older name. It stands for Kestrel 1 emulator. The current name of the machine is, as you can see down here, is going to be ForthBox. But I will change names once the project more comes to completion. But so once I have the environment built, which I have, as you can see here, I've got a script called make disk 0. That builds a binary file called disk 0. This is an emulated disk, imagine. And if I just run K1EMU, it actually boots off the disk and then launches and runs directly into a program I call IMF, which basically stands for Interactive Monitor for ForthBox. And as you can see here, it's presenting the CPU register values. So as soon as the machine turns on, it just drops right into the machine language monitor. So what are these registers? If you're familiar with 6502, some of these will already be recognizable. You have your accumulator, your X and Y registers, you have your stack pointer, and your flags register, and of course your program counter. But one of the things that you'll notice is that these are wider registers than in the 6502. And that's because the 65816 is a proper 16-bit processor. It does, however, have an emulation of the 6502 mode, meaning you can actually adjust the register widths, narrow them all down to 8 bits, and actually run legacy 6502 code. You'll not be able to exploit undocumented opcodes, though, because they're all documented now, and they don't do what you expect them to do. So basically, you can type letters to execute commands. As you can see here, the letter R just brings up the current set of registers. You can also dump the contents of memory. So I will start with dumping the actual binary code for the monitor itself, starting at EC00 hex. And as you can see, it will provide you with a display there. If you just keep hitting enter at this point, it just keeps incrementing and displaying. So you can actually conveniently display a large amount of data that way. Let's see here. You can also jump to a program as well with the G command. And the way you get back into, someone's got some really bad noise. So when you execute a break instruction, as you can see here, the monitor tells you why it dropped back into the machine language monitor. So in this case, it recognizes that it came through a break instruction. And as you can see here, it also reflects the current value of the program counter. Now there is a command you'll probably notice. What's with these colons here. It's actually a mnemonic to the user that you can actually type the colon, and it is now waiting for input, which allows you to change certain values as you go across the display. So for this example, what I'm going to do is I'm going to change our program counter to the start of some memory, and I'm going to hit enter there. But if we look at that memory, it's just loaded with zeros. So if we type go now, right away we get execute a breakpoint, because on the 6502 and the 65816, the break instruction is just 00. You'll notice that the program counter increments by 2. A lot of people don't realize this, but the 6502 actually specifies that the break instruction is not a 1-byte instruction. It's actually a 2-byte instruction. It is intended to be used as a system call function, where that is the opcode. That's what actually executes the break. But this is actually intended to be a signature byte specifying what system call to execute. So, and I actually have a PDF copy of the original MOS 6502 TIM documentation, which explains this. Although, strangely, the TIM monitor fudges the program counter to make it look like a 1-byte instruction. I never understood that, why they did that. But anyway, I bring back the break to its original intended purpose, since it's a 2-byte instruction for me. So with that being said, we can actually type in a program. I actually have, give me 1 second here. I'm going to exit out of that. I'm actually going to type in a program for you. You can see from the dump what it's going to do basically. But I will just demonstrate that this actually is a functioning environment, and hopefully I won't screw this up. So 8317, and as you can see, this is not what one today would consider to be a very useful or convenient environment in which to run software. But back in 1979, early 80s, for inexpensive computers, this is what you this is pretty much what you ended up having to do. Oops, that's not what I want. Come on, 4010. And so basically I'm entering the message portion right now. And almost done. Oops, no, I don't want to do that. Let me just make sure that it's unchanged. Oh, come on. Performance anxiety. All right, so now if I do the dump there, I can see everything is there. So if I now dump the registers, spacebar, by the way, when you're in alter mode like this, spacebar preserves that particular nibble. So I can actually, I don't have to alter everything. Make sure of that. And so if I start execution, hello world, what is your name, right? So typical hello world example demonstrates that we can actually alter memory, we can inspect memory, we can alter and inspect registers, and we can commence execution of programs. So this is essentially feature complete. There is, however, it is not ready for release yet. There are some missing functionality. For example, if I alter this and I alter the emulation bit to 1, so if I so now if I change the if I were to execute that program in 6502 native mode, for example, and I execute, you'll notice that it just deadlocks. And the reason it's doing this is because I have not finished implementing all the trap and CPU interrupt handlers yet. So there's still some functionality missing. Probably by end of February, I'll have this all worked out, and it'll be version 1.0, if you will, documented and uploaded, released, if you will, on the website. which basically is useful because now I've got a how would you say, safety net, where once I actually do start working on the fourth interpreter for the environment, if something goes terribly awry and it's executing random code, I can at least use this machine language monitor to inspect what's going on and find out how things are working, which is basically why I took this bit of diversion. So that's the update. As you can see, it is actually running and executing code. It is, oh, and for those wanting to know the actual source code of that hello world, that's the actual source code that I typed in. So you'll notice that there are a couple of unique instructions for the 65816, such as the set and rep instructions to alter the register sizes and such. So yeah, that's basically all I have at the moment. It is functioning. I expect the monitor to be feature complete I'm sorry, to be essentially released by end of February, and work on the actual fourth interpreter will commence, I'm hoping, by March. So that's where I'm at. Anyone have any questions?
You said that you can change the register sizes. Is this per register or are there an old mode and a new mode?
So there are two register size bits. One's M and one is X. Changing the M bit alters the size of the accumulator and the size of the operations performed when you access direct page memory. If you alter the X bit, that alters the size of the index registers. So X and Y both share the same size, but they are changeable independently from the accumulator. And as you can see, the processor is able to address up to 16 megabytes of memory, which is quite a chunk of space for something that is 6502 compatible.
Any other questions for Sam? I'll take that as a no. So going forward, our next speaker, John, you're on deck. You ready to go?
You say me?
That's you.
That's me? Okay.
This is the Core I fourth FBA talk, and it looks like we may assign your long video, hour-and-a-half video, to the populace as homework, so that we can better appreciate it and maybe talk about it next month. Does that seem like a reasonable thing to do?
Yeah, I think it'd be great. Where's the share screen? Why am I not seeing it?
You should have a toolbar along the bottom of your screen, and from
there
the
it is,
right,
right in the middle.
record, raise hand, and share screen.
Got it. Use Teams a lot at work.
We can see your screen sharing now.
My condolences.
Yeah,